Okay, this VodCast is going to talk about limiting and excess reactants. In the last VodCast, we were concerned with percent yield and finding out how much of a product we were producing, if we were producing a theoretical yield of 100% or some percentage below that, which would have been an actual yield. Now what we're going to look at is we're going to look at a reaction that between reactant and another reactant to see how much product will be produced from those two reactants. Now, this starts first of all with a couple of definitions. The first definition we're going to look at is a definition for what is called limiting reactant. Limiting reactant is exactly what it says it is. It is the reactant that limits how much product is going to be produced. And it does that because in a reaction, it is completely used up. Okay? The limiting reactant is going to be used up, and once it is used up, that causes the reaction to stop. The reaction can no longer go any further because there's no longer any of this reactant. Thus, it limits the amount of product produced. Okay? That is why it's called the limiting reactant. The other reactant we want to talk about is what is referred to as the excess reactant. The excess is exactly, again, what it says. It's going to be the reactant in excess. And I've kind of been trying to lead you to this in some of the previous problems when I said this reactant is in excess. Okay? It's the reactant that's going to be left over, and when the reaction is stopped, okay, there is always some of this left. Hence, it is the excess reactant. Now, what I want to do is give you some not chemistry examples, but some examples that are along the lines of limiting and excess. They're going to seem a little weird, but okay, it's just to get you the idea of what it means to be limiting and what it means to be excess. This one actually came from a former student. So let's say you are working at McDonald's and you are making orders of McNuggets. And so you have 250 McNuggets, and you have 35 containers to put those McNuggets in. We want to know how many orders of six McNuggets can you actually make, okay? This is really a limiting and excess problem. So what you're going to do is, first of all, take your 250 McNuggets, and we're going to divide that by 6 McNuggets per container. So if I take 250 divided by 6, that gives me 41.6 containers I can make. Now, this is a case where I can't make 0.6 of a container, so we're not going to worry about the 0.6. I can make 41 containers. So I have enough McNuggets for 41 containers. Okay? So I have 41 available. Okay? But I only have 35 containers to use. Okay? So what is going to limit how many McNuggets I can sell? And in this case, it's going to be the 35 containers because they are going to get used up. So the limiting is the containers, and the excess is the nuggets. And I know that seems kind of weird, but it's all getting you thinking along the lines of limiting and excess. I have kind of another weird one here. Okay, you have 5,350 wheels, 3,133 bike frames, and 2,785 handlebars. How many bikes can you make? Okay, now, how many two-wheel bikes? okay, just so we get rid of the whole unicycle issue. Okay, so how many two-wheel bikes can you make? So there's going to be a limiting and an excess, and what we want to figure out is what is limiting and what is excess. So one of the first things we need to do is we need to take this 5,350 wheels and divide that by 2 to see how many bikes we can actually make. So we're going to take 5,350 divided by 2. So I can make 2,675 bikes with 2 wheels. Okay? Well, each bike needs a frame, and I have 3,133 frames. And each bike needs 1 handlebar, and I have 2,785 handlebars. Okay, so I guess what's going to limit my bike production is going to be the smallest number. The smallest number is the number of wheels. So I can make 2,675 bikes. Now, so this is limiting. These 2 then are excess. And then one of the things we can figure out is, okay, how much excess do I have? How many excess frames do I have? Well, I would take 3,133 minus 2,675, and what that would tell me would be how many frames I have left over. So I have 458 leftover frames. Okay, and that's one of the things that we're going to want to find out when we actually bring this to a chemical reaction, is we're going to want to find out how much is left over. And we can do that same thing with the handlebars. I have 2,785 handlebars minus 2,675. So 2,785 minus 2,675. I have 110 leftover handlebars. And so, again, kind of weird, but it's the same thought process that we need to apply to a chemical reaction. Okay? Now, I'm going to skip that example. So if we look at a chemical reaction in a perfect situation, okay, this would be a chemical reaction in a perfect situation. Okay? There are 2 moles of NO that need 1 mole of O2, and that's going to produce 2 moles of NO2. So that would be a perfect reaction. But we never have perfect reactions. So what I'd like you to do is watch this little video clip about this same exact reaction.
Nitric oxide and oxygen gas are reacted in a 1-to-1 mole ratio. There are 4 molecules of NO in the left bulb and 4 molecules of O2 in the right bulb. The valve separating the bulbs is opened, allowing the gases to mix. The reaction occurring is 2NO plus O2 producing 2NO2. 4 molecules of NO are reacting with 4 molecules of O2. The 4 NO molecules require only 2 O2 molecules for reaction. Note the 2-to-1 mole ratio in the balanced equation. Therefore, 2 O2 molecules remain after reaction. The reaction stops once the nitric oxide gas runs out. NO limits the amount of product that can be formed and is therefore called the limiting reagent. Oxygen gas is present in excess.
So you can see when we have this 4-to-4, okay, molecule ratio, okay, we have 2 too many oxygens. So if you look at the picture right now, you see there's 2 oxygens left unreacted. Those would be your excess reactant. The 2 NOs, okay, or actually the 4 NOs, all actually got used up. So those were your limiting reactants. So that's just trying to show this in a chemical reaction format. Now, we're going to try to do this in a reaction. Okay? So it's the same thought process, but it gets a little complicated real fast. So try to hang with me, and if you need to, slow down. Okay, slow down and repeat some things. But here I have a fairly simple single replacement reaction, and I'm going to react 0.855 grams of chlorine and 3.205 grams of KBr. So that's what I'm starting with. I am starting with 0.855 grams of Cl2 and 3.205 grams of KBr. And one of the things that you're going to find that I really want you to focus on is that you need to pay attention to the fact that this is what you have. I have this amount. Okay, that's what I'm starting with, and they are both the reactants. Okay, rewrite this. That's what I have. What I'm trying to find out is which one of these is limiting, which one is excess, and then I'm going to find out how much excess is left over. Then I'll worry about this question. Okay, so here's the thing. What you need to do in order to find out which one of these is limiting and which one is excess, you need to do a mass-to-mass calculation between the two reactants. Okay, that's what you want to do. We are not going to worry about any products right now. All I want to know is if I have this mass of chlorine and this mass of KBr, which one of those two is excess? Now, this is the hard part. How do you do this? Well, you pick one and then find out how much of the other one you would need to react with it. Okay? So it's very important. This is how you start. You pick one reactant and use it to find the amount of the other reactant you would need. Okay, that's what you have to do. Okay, so now that's exactly what I'm going to do. And I am just going to pick the 0.855 grams. So I'm going to start with 0.855 grams of Cl2. And this is just a shot in the dark. You just pick one. And what I want to do is a mass-to-mass to the KBr. Now remember, this is this 3.205, that's what I have. But this actually kind of goes back to the theoretical idea. I want to find out theoretically how much chlorine I actually need to react with that. So I'm going to do a mass-to-mass, so I'm going to take and find the molar mass of chlorine, which is 71 grams. And then I'm going to calculate the mole ratio between those two, which is 2 to 1. So there's 2 moles of KBr to 1 mole of Cl2. Then I'm going to find the molar mass of KBr, which is 119 grams of KBr per 1 mole. Okay, and I'm going to do that calculation. And when I do that calculation, what I find is that I get 2.87 grams of KBr. Now, this is where you start getting a lot of numbers, and you have to know what those numbers mean. Okay? Now, it all goes back to up here. This is what you have. What I just calculated here is what I need to react with that. So this is theoretical amount over here. I have 3.205. I need only 2.87 grams. So actually I've just calculated my limiting and my excess. Okay, my limiting reactant is going to be chlorine. So Cl2 is actually limiting. Kbr is excess because I have 3.205 grams, and I'm going to subtract this right away. I only need 2.87 grams. So what I have is 0.335 grams of KBr left over. Okay, so did you follow all those numbers? Because it's really a matter of tracking numbers. Okay, so there's a lot going on there, and so you really have to follow numbers. And the reason why Cl is limiting is because it all got used up. Now, in this particular problem, I'm not going to lie, we got lucky and we chose the right reactant first. That's not always going to happen to you. Okay? Now, what I want to do is go back and answer this question. Okay, and this question is, okay, how much Br2 is formed? Br2 is a product. Okay? Now, whenever you are finding the amount of product that's formed, you may only use the limiting reactant. So I want to make a star here, and I want you to write that down. Whenever you find the amount of product produced, you may only use the limiting reactant. Only, okay? You may only use a limiting reactant. So in this case, what I want to do is I want to take my 0.855 grams of chlorine, and I want to find out how many grams of Br2 are formed. So this is just a straight old standard stoich problem. Okay? So, set this up, mass to mass. And so that's going to be 1.93 grams of Br2 is produced. And again, that would actually go back to what we were doing the other day. That's a theoretical yield. That would be, in theory, what could be produced. Okay? Let's look at another example. Okay, give me a chance to write this down. So 18 grams of aluminum are combined with 50 grams of HCl. I want to know which is reactant is limiting, which is excess, and how much excess is left over. So obviously one of the first things is you do not have an equation. So you will need to write the equation. So I'm taking aluminum plus HCl, and so that looks like a single replacement reaction with an acid, with an acid. So that's going to give me aluminum chloride plus hydrogen gas. And of course, we do need to balance. So 2, 6, 2, 3. Okay, so again, you want to start out with, what do I have? Okay, I have 18 grams of aluminum, and I have 50 grams of HCl. Those are my two reactants. Okay, what you want to do is find what you need. Okay, so I want to do a mass to mass calculation between those two, and I just need to pick one of these two and figure out how much of the other one I need. Okay, so I am going to pick the 18 grams of aluminum. And what I'm going to do is find the HCl needed to react. So this will be a mass to mass again with the two reactants. So I'm going to take 18 grams of aluminum, and I need to change that to moles. So 1 mole all over 27 grams of aluminum times a 6:2 mole ratio, so 6 moles of HCl to 2 moles of aluminum, and then times the molar mass, which is 36.5 grams of HCl to 1 mole. So, do the math. Okay, and in doing this, I got a really high number, so I'm going to check it again. Okay, got the same number twice. So this means I need 73 grams of HCl. So you got to stop now, and this is where you need to think. Okay, need to think up here. This is right here in this box. This is my half box. Okay, and what this reaction means is 18 grams of aluminum needs 73 grams of HCl. The problem is you only have how much HCl? Okay, and the issue is I only have 50 grams of HCl. So for that 18 grams of aluminum, I do not have enough HCl. So that means then that I don't have enough HCl. So HCl then is the limiting reactant. Because I only have 50 grams of it, and I need 73. So that means aluminum is going to be excess. So that's my excess reactant. Now, here's the problem, okay? I have identified my limiting and my excess. The only problem is I haven't identified how much excess I should have left over, because I cannot just subtract these two numbers. Okay, I cannot just subtract them because 73, I don't have that. I've never had that. That 73 just showed up in a calculation, so that 73 is a number that I never have. So this is the case where you're going to have to do another Stoic problem to finish answering the question, and this is going to happen to you. If you don't choose correctly the first time, and there's no magic bullet to tell you how to choose which one, you may have to end up doing two Stoic problems. So I'm actually going to have to do another stoic problem starting with 50 grams of HCl, and I'm going to have to find out how much aluminum I need to react with it. The nice thing is, once you've done this once, you actually have all of your numbers because they're just going to flip-flop from above. So I need to change my HCl into moles, so 36.5 grams. Mole ratio now is 2 moles of aluminum to 6 moles of HCl, and then it's going to be 27 grams of aluminum to 1 mole. Okay, so if I just stop here for a second, which I hate doing, but if you look at these two setups, okay, they're just opposite of each other. Okay, that's all they are. So now, when I calculate this out, what you'll find is you're going to get 12.3 grams of aluminum. And again, this is what you need. Now, go back. What do you have? You have 18 grams of aluminum. You only need 12.3 grams. So again, now if you would have chose correctly, you can see that aluminum is excess. How much excess? Well, I'm going to take the 18 grams that I have minus the 12.3 grams that I actually need, and that will tell me I have 5.7 grams of aluminum left over. Okay? So, I know that's a lot, okay, but this is the whole idea of limiting in excess. You should now have enough information to complete a worksheet.